3.5, solving nonlinear systems, is on page 132 through 135, systems of nonlinear equations. Okay, so previously we learned how to solve systems of linear equations by graphing, substitution, and elimination. Well, you can also use these methods in solving nonlinear equations. Alright, so a system of a nonlinear equation has at least one equation that is nonlinear. Okay, for example, right here, we have a quadratic equation and a linear equation. If I solved for x and y here, that would be solving the systems of a nonlinear equation. Alright, what type of solutions can I have? Well, if I have a parabola and a line, just like this example right here, and they don't touch, that would be no solution. And in our quadratic, I'd actually have like a square root of a negative number, which we wouldn't use I, we just would write no solution. If I solve and I have a parabola and a line that touch at one point, then there's one solution. And that would be an example where we have the square root of 0. And then if I have a line and a parabola that touches at 2 points, we have two solutions, and that would be like the square root of a positive number. Alright, let's get on down here. We could also have two quadratics, right? Two parabolas. And therefore, two U-shapes, and if they don't touch, again, that would be no solution. If they touch only at one point, one solution. And if they intersect at 2 points, then it would be two solutions. Alright, and we will do both of those and more in this section. I'm going to scoot all the way up, maybe make it a little bigger here. And let's go on to concept 1. Solving a nonlinear system by substitution. Okay, so I can really probably pick either variable, but looking at this, since I have that x squared right there, I definitely want to solve for y in this one and then replace or substitute that x in there. What I mean is I'm going to go ahead and subtract x from both sides of the equation right here, and I get y equals negative x plus 4. Right? And what I'm going to do is basically take that negative x plus 4 and substitute it right there in for y. Alright, so let me write that over here. So I have x squared, let's see, x squared plus x, and then it's minus y, but I'm going to substitute negative x plus 4 in for y equals negative 1. Alright, now I have my equation which I'm going to solve. It is a quadratic. So what I'm going to do is distribute here and then try to get 0 on one side of the equation. Okay, so I got x squared plus x plus negative times a negative is positive x. Negative 1 times 4 is negative 4 equals negative 1. Perfect. What I'm going to do is combine my like terms right here, and then I want to get 0 on one side, so I'm going to add 1 to both sides of the equation. Okay, next, x squared plus x times x plus x is 2x, and then negative 4 plus 1 is negative 3 equals 0. Now that I have 0 on one side of the equation, I'm going to look to solve, and in this case, could I solve by factoring? Can you think of two numbers that multiply to give you negative 3 that add up to give you positive 2? Well, I can. Alright, so, and that is 3 and 1. So, I can set x here. I know it's negative, so it's a positive times a negative to give me a negative. And if I have positive 3 and negative 1, they multiply to give me negative 3. They combine to give me 2. Alright, so now I have that. I'm going to set each equation equal to 0. It's called the zero product property. So I go x plus 3 equals 0, x minus 1 equals 0. Here I subtract 3 from both sides. Here I add 1 to both sides to solve for x. X equals negative 3 and 1. Okay, perfect. I solved for x. Now, what I really need to do is look for points of intersection, right? So I also need my y's. Alright, so what I have to do is I'm going to take this negative 3x, I'm going to plug it into this equation right here and solve for y. Because I'm looking for ordered pairs, and I'm looking for two ordered pairs since I have two solutions for x. Alright, so here we go. Let me scoot this out a little bit. Now, I have y equals the opposite, and I'm going to put in negative 3, and then plus 4, and I get opposite of negative 3, which is positive 3 plus 4 is 7. And now I have the ordered pair of 3, 7. I think I'm going to write it over here. Voila. Next, I got y equals, I'm going to plug in 1 for x. I could use f of 1 if you want, but it's really y in this case. And I have the opposite, place x with 1 plus 4. And negative 1 plus 4 is 3. So now I have 1, 3. And those right there are my two solutions, those two ordered pairs. That's the answer I'm looking for. 3, 7 and 1, 3. Okay, there's a lot going on there. Totally understand. You just want to take it one step at a time. You're going to use substitution here. Again, I would use solve for y, substitute for y, put it into an equation. You're going to solve the quadratic, and then you're going to go back and solve for ordered pairs. X, y ordered pairs, right? Okay. Go ahead and give number 2 a try. Pause and give it a try. When you are done, unpause, and I'm going to show the answer now. Okay, so your solution here is negative 6, 19 and 2, 3. Check out that work. And then we can go on to number 2. Concept number 2 is solving a nonlinear system by elimination. And this also works really well, and especially if it's set up for it. And in this case, it really is. Okay, so if I go ahead and make a line underneath, what am I going to eliminate? Well, if you look, I have a negative y and a positive y. So, they eliminate, right? Negative y plus positive y is 0. I don't have to no longer worry about my y's. I combined my other like terms. 2x squared and x squared is 3x squared. Negative 5x and 2x is negative 3x, sorry. And then negative 2 and 0 is negative 2. And what type of equation am I working with? A quadratic. And I'm going to go ahead and solve that quadratic. And I'm going to add 2 to both sides. And I'm just going to scoot over a little bit here, but I get 3x squared minus 3x plus 2 equals 0. Alright. Can you factor this? Well, maybe, but I'm not even going to try. It doesn't look factorable to me. I'm going to go ahead and just plug it. Because it has a 3 as an a term, I'm just going to plug in my quadratic formula. So a equals 3, b equals negative 3, c equals 2. X equals the opposite of b, a negative 3. So minus a negative 3 is really going to turn to a positive 3. Plus or minus the square root of negative 3 squared minus 4 times a, which is 3, times c, which is 2, all over 2 times a, which is 3. Let's go farther. X equals 3 plus or minus the square root. Negative 3 squared is 9. Negative 4 times 3 is negative 12 times 2 is negative 24. All over 2 times 3, which is 6. Alright, so I'm going to combine here what's under my radical. I'm going to go up here and do that. And I have x equals 3 plus or minus the square root of negative 15 all over 6. And look here, I have a negative under that radical. So in this case, I am actually not going to make an imaginary number. It is no solution because of that negative. That is the answer I'm looking for. And again, it is because that negative in the radical. Okay, I am also going to go ahead and do number 4 for you guys. So pause and look at that longer if you like. I'm going to scoot it up just because it's a little different. So you're not going to have a try this problem on this, but you get some in the homework. Okay. Alright, number 4. Same idea. I am going to look to eliminate here in this case. And look, I got that negative y and positive y in these equations. And therefore it cancels out again. So I'm going to go ahead and combine like terms. 2x squared and x squared is really 3x squared. 4x and nothing else is 4x on that side of the equation. On the other side of the equation, I have negative 2 and positive 2, which again will cancel out, so I get 0. Okay, I'm going to solve the quadratic. But look at this one. It's got x and x in both of them, and therefore that's the greatest common factor. I'm going to pull out the x. I am left with 3x plus 4 equals 0. Next, I'm going to set each factor equal to 0. X equals 0, and 3x plus 4 equals 0. Alright, so I got one solution already. I'm going to subtract 4 here. I get 3x equals negative 4, divide by 3. And my other equation here, x equals negative 4/3. Shoot. Negative 4/3. Okay, so now I have those two equations. But what do I need to do now? Well, I need to take those two equations and I need to substitute them in to solve for the y, because I'm looking for ordered pairs. So I'm going to take this one right here. Okay, so it's x squared plus y equals 2. I'm going to solve for y, so I'm just going to subtract x squared from both sides. And I get y equals negative x squared plus 2. And I do that just to make it easy on myself, because then when I plug in my x's, I solve for my y's. Okay, I'm going to start with 0. So I plug it right here. Y equals the opposite of 0 squared plus 2. Well, 0 squared is 0. Then the opposite of 0, or negative 0, is just 0. Plus 2 is 2. Okay, so what's my ordered pair? 0, 2. Do the same thing for this one. Y equals the opposite of negative 4/3 squared plus 2. Okay, so negative 4/3 squared. Negative 4 times negative 4 is 16. So I get the opposite of 16. 3 times 3 is 9. Okay, plus 2. And I'm going to make it 2 over 1 here. And what I'm going to do is multiply 9 to both top and bottom to get common denominators. And now I have negative 16 ninths plus 18 ninths. And that is 2 ninths. And that's what y is equal to. And so, last but not least, I'm going to write my ordered pair. And just because I have a little room underneath here, I'm going to write it here. I have negative 4/3, comma, 2 ninths. Alright, so I have two solutions. This one right here, and this one right here. Those are the two answers I'm looking for. Scoot it out a little bit. You can take a look at that whole thing. Take some time. Look that over. Sorry I don't have a try this problem on this one. And then I'm going to come back and do the last one for you in the next video.